Hi guys. Welcome to our 8th lesson about the ROS2. In this lesson, we're going to see exactly the same robot we created in the previous lessons. But we're going to introduce a new concept about ROS. The launch file system. The basic idea is to use a launch file in order to start all our nodes. For instance, the robot code, the visualizer, the robot model, the joystick node, and everything you need for simulation automatically. As you can see here in this terminal, I needed only one terminal and one command line in order to start my package. We can see Telema, the code I wrote in the past lesson. Then the joy node needed to read the joystick as input device. Then is ROS2, the visualizer, or better the interface, where the robot gets displayed. Plus the robot state publisher, this is a node, which is needed every time a robot must be controlled or moved somehow. This package is used for the kinematics and for the transformations between the joints of the robot. So now, let's start by closing now my environment and clearing my terminal, and now we are going to see how to create a launch file from scratch. Inside your package Telema, you should not have this config folder and this launch folder. They are missing right now, so create now a new launch folder inside your package folder. Then inside this folder we have a file. This file is going to be called telemalaunch.py. Let's open it using your preferred terminal to edit this file. Again, as in the previous lesson, I already created the file, so we can go through it line by line quickly. First, all these packages are needed, so they must be imported. We import the function getPackageSharePath from AmentIndex Python. Then we import the parameter value from the parameter description module. Then we import the node from the module actions, and we import command and launch configuration from the substitution module. From the actions module, we have to import the declare launch argument. The execute process and opaque function can be removed, since they are not going to be used in this example. Last but not least, the launch description function needs to be imported as well. The module OS is necessary for creating the path to the single files on the system. The very first step is to define a new function with the name generateLaunchDescription. This is a standard name and should not be changed. After that, we can define a launch description object, LD. Note that LD is going to be returned by this function at the end by typing return LD. LD is in this case a launch description object which stores all the actions and all the commands that should be executed for launching the program. Let's define a variable which contains the path to our package. In this case, Telema. The function getPackageSharePath looks for the package Telema and return its path on the local system. The path to the URDF model is passed concatenated to package path by using OSPathJoin and stored in URDF model path. The same for the config.rviz configuration file. It is stored in the config folder inside the package folder. This file contains all the configuration data for ROS2. It is automatically generated, and we will look into it later in this tutorial. Furthermore, let's define a new variable robot model arg. This is a declare launch argument, which requires a name robot model, a path to the file URDF model path, and a description. The description is not necessary, but it is a good habit to define one. Now, let's define another declare launch argument object, which requires a name ROS2config, a path to the configuration file, and a description. Then a robot description is necessary. This is a parameter which is used later. To create this object, the command zacro need to be passed. Please be aware that there is an empty space after the word zacro. You cannot omit this space, otherwise you will get an error. Then the second element is launch configuration robot model. This robot model here is referring to this object here. This is robot model. In other words, the robot model, which contains the path to the URDF file, is going to be processed by zacro. Last but not least, the value type can be specified. In this is case string. Now the single nodes need to be defined. Let's start defining main node. We pass the package name Telema, a name for the node Telema node. The node name is free. There are no constraints here. This is not the case for the executable name. The executable name must match exact the same executable name defined in the setup.py file. In this case, Telema is defined as executable name of the program, so it must be used in the launch file as well. The output should be screen. This means that all information are redirected to the terminal. The namespace is a very important parameter, but since we are not using one, we can put none. Let's define another node. This node is the robot state publisher node, which is responsible for sending the transformation data through the network. To define, it is very straightforward. Package name is the robot state publisher. The executable is called robot state publisher. The name is robot state publisher, and the output is simply screen. Important here is the last parameter. We need to pass the robot description, which is this variable here. It was created few steps above by running Zacro followed by the path to the robot model. The robot state publisher is installed automatically when ROS is installed, so there is no need to install it separately. It is a very important package, which is necessary every time a robot, a process, or a system simulation is needed. Now let's define the joystick node. This node will start the node for the joystick needed for controlling the robot. Even this implementation is very straightforward. Package name, Joy. Executable, Joy node. Name, Joy. Output, screen and none as namespace. For the ROS2 node, identical easy implementation. We define ROS node by passing to the class node the following parameters. Package, ROS2. Executable, ROS2. Name, ROS2. Output, screen. Namespace, none. But pay attention to the arguments. Here, the variable ROS config needs to be passed. ROS config stores the configuration information for ROS. Do not forget the -d is first argument here. In short, ROS config was already defined in this place, and here an argument was created. The configuration file is stored inside the variable ROS config, which is passed later during the node creation. Thus, we can now fill out the launch description object with the elements created above. This is a very easy step. Just take the object defined at the beginning, LD, or better the launch description object. Since it is a list, it is possible to add all those actions together. Let's start from the main node. Then, we will pass the robot model argument as second element to the list. The third element is the robot model arguments. The fourth element is the robot state node. Then, the joystick node is going to be passed. Finally, the ROS configuration as ROS arg, and then the ROS node are added to the launch description. At the end of the function, all this stuff is returned. Now let's close the launch file for a moment, and let's change the setup file, since it is necessary to install the launch file as well. In this file, those two lines of code need to be added. First, the telema launch.py file, which is inside the launch directory in the source directory, is going to be installed into the directory launch inside the installation directory. Secondly, the second file must be installed. This file contains the configuration information of ROS. Later, we are going to see how to create such file. Once those two lines of code are added to the setup file, the job is done. Now the setup.py file can be closed. Open a terminal and type "calcan build packages select" followed by the name of the package, in this case, Telema. Do not forget to source the setup.bash file. Finally, all the nodes can be now started by typing ROS2 ROS launch followed by the package name, followed by the launch file, created above. The environment gets now started and all the nodes start as expected. If I move my joystick, then the robot is moving as well. Now about the ROS configuration file. How to create this file. Probably you will not find this in your package already. In this case, it will be exported from ROS configuration menu. The first time running ROS, there will be probably less items here on the left side. I'll remove now some added features for showing purposes. So, just click on Add, and then click on the wanted widget. One of the most important widget is the robot model. Let's import it. The reason why no robot model is visualized right now is that the topic name should be rightly added in the field description topic. The second important one is the TF module. It is used to visualize the relationship between the different frames. Once imported and rightly configured, this configuration file can be saved as a configuration file. Please remember to save it in the configuration folder inside your package folder, inside the source directory. We are done. Let's recompile the package again. Calcan build packages select followed by the package name. Resource the setup bash file again and relaunch the Telema launch file again. As you can see, RVIZ did load the saved configuration automatically. Every needed module is called and perfectly configured. Everything was launched by a single file, the launch file. No need to start different nodes in different terminals. Okay guys, this was a very tough lesson today. Please remember that you can only master all this process by practicing a lot. Thank you very much. See you in the next lesson.